Lesson 6.2, Day 2, more anti-differentiation with natural log and exponentials, as well as the simplifying cases. So we're going to start with reviewing the derivative of e to the x. E to the x is the easiest derivative, so it'll be the easiest antiderivative. Its derivative is itself, so its antiderivative is itself. So it's e to the x, and as before, plus the constant. 1 over x, if you think back in time, who had a derivative of 1 over x? And hopefully everybody's remembering, that is natural log of x, has that as its derivative. But if I work backwards, I have to be careful because I can only take the natural log of positive quantities. This, we have no way of knowing if it's positive or negative. So when we work backwards, we put in absolute values, and then we put plus c at the end. So those are our two new ones that we're going to incorporate into the additional simplifying algebraically before we use the power rule. So I'm looking at number 1, the antiderivative of 3 different things. The first is 2, that's what we did the other day. So 2 becomes 2x, because who has a derivative of 2? 2x, the linear function. Plus, who has a derivative of e to the x? E to the x, so it repeats itself. Minus, and then this one is your power rule in reverse. So leave a space in the front, put down your x, raise it up 1 power, divide the coefficient of 1 by the new power. So we get 1/2 x squared. And if you take its derivative, it would be going back to x. Plus c at the end. My next example, I have 6 over x minus 8 over x squared. Now the 6 over x is very similar to the 1 over x. The difference is it's 6 times as large. So when I do the antiderivative, if it's 6 times as large, it's 6 times the natural log of the absolute value of x. Okay. My next term after that, I'm going to look at this. It's not just over x though, it's really over 8, it's over x squared. This term is not a natural log, because I have to remember this is 8x to the negative 2. This one's going to involve the power rule. So I'm going to leave a space in the front and say if I increase my power by 1, it's going to go from an x to the negative 2 to an x to the negative 1. Then I have minus 8 in front. If I divide by the negative 1, it becomes plus 8 in the front, plus c at the very end. And that is my antiderivative for that one. Now we're going to get to the point where we start doing simplification. In this problem, I have multiplication. I have the binomial x squared being multiplied, the x squared, the quadratic, multiplied by the binomial 1 plus x. Our first move is to distribute and say x to the second plus x to the third. In order to apply the power rule, you can't have any algebraic simplification left. So we perform the algebra, then we can apply the power rule. This becomes x to the third, increasing the power by 1, with 1/3 in front, plus increase the power by 1, you get 4, divide the 1 in front, you get 1/4, plus the constant at the end. My next one, there's algebraic simplification because the binomial is being squared. So I first square that binomial. I get 9 minus 6x squared plus x to the 4th dx. Now that I have all of my terms listed out, I can then apply the power rule in reverse. I take the 9, work backwards to get 9x, minus this x goes x to the third. In front, 6 divided by 3 is a 2. The next term, I have x to the fifth. Go back to its front. I have a 1, so it becomes 1/5 plus c at the end. My last two examples involve algebraic simplification. So if I'm looking here, I see some division. Every term in the first case here is divided by x to the third. So I'm going to say, well, what's the result if I divide everybody by x to the third? I subtract my exponents, and I would get x to the fifth, because of 8 minus 3, minus 2x to the third, plus, now this one, there's no x's up here, so I'm going to do this one as a rewrite as 4x to the negative 3. And that's my simplification. So everybody's being divided by that x to the third. Then I get my antiderivative by applying that power rule. X to the sixth, 1/6 in front, minus, this becomes x to the fourth. The 2 divided by 4 is 1/2. And then here, x to the negative 2. Take that 4 divided by negative 2, you get minus 2 plus c at the end. The last problem we have, we're dividing all the terms by 3x. So when I divide by 3x, 18 divided by 3 is 6. There's no x's to cancel, so it actually ends up being 6x to the negative 1. Minus, there's no coefficient here, so this one technically is 1/3, and the x's would cancel each other out, so I just have 1/3. Plus, the 2 and the 3 become a fraction, 2/3, and here I have some x's that cancel. X to the third over x becomes x squared dx. There's my simplification. I'm ready to do the antiderivative. Well, now when I'm looking at it, this is 6x to the negative 1. I go to add 1 to the power, I get x to the 0, and I can't divide by 0 in front, so it's a trigger. This one is a problem. So if I look at it a little differently, this is like 6 over x. That's that special case. So it's 6 times 1 over x, so it's 6 times the natural log absolute value of x. Minus 1/3 is a constant, that becomes 1/3 x, plus, and then my last one leaves some space, it becomes x to the third. Dividing 2/3 by 3 is like taking 2/3 times 1/3, and I get 2/9 in front plus c at the end. And that's it for today's lesson.